Welcome to my algebra class. We are on chapter 4, section 10. These are problems that have, in some cases, no solutions for three reasons. First of all, there might not be enough information. In this example, it says 6 people have a total of $40. How much does each have? Well, you don't know if they share the $40 equally or how much each one has more than the other. So there's really not enough information to set up the problem. A second possibility is an unrealistic result. They said, in this example here, the product of 3 consecutive negative numbers is 24. Well, if you have 3 consecutive negative numbers, for example, -2, -3, -4, you multiply them together, your answer is always going to be negative. So that's an unrealistic result. You could never get a positive number. And a contradiction is that you can work the problem out. However, the facts are false. So 7 dimes is the same as 3/4. 7 dimes is 70 cents, and that does not equal 75. So that's a false statement, a contradiction. So there's no solution. The second and the third example is you can work out. They will work out, but your results are either unrealistic, they don't equal what you're supposed to get, or they're a contradiction. The vocabulary for 410 is right here. So you could pause the video and write these down. There are 2 more examples of not enough solution, not enough information, an unrealistic result, and a contradiction. So you can pause the video and copy those down. When done, you need to get your paper for your assignment and turn to page 176. On 176, we're doing problems 1 through 12. After you had your paper, skip a line, you have the title. We're doing number 2. Number 2 says a child's bank contains $6.30 in dimes and quarters. There are twice as many dimes as quarters. How many of each kind of coin do we have? We can use a chart, a value problem set up for this. So we have the coins, dimes, quarters. And we have the number of each, the value of each, and the total value. We know the value of a dime is 10 cents and a quarter is 25. And it says there are twice as many dimes as quarters. So they're building on quarters. Dimes would be 2x. So the total value of the dimes would be 2x times 10, which is 20x. And the total value of the quarters is 25x. The value of all the coins is $6.30, but since we use 10 cents and 25 cents, we'll use 630 cents for the total. So 20x plus 25x has to equal 630. 45x equals 630. Divide both sides by 45. And using your calculator, 630 divided by 45 gives us a total of 14. So there's 14 quarters, and they want to know how many of each kind. So 14 quarters and twice as many dimes, 28 dimes. So that one worked out. Problem number 4 says Kyle spent $4.95 to buy 15 stamps in 25 and 40-cent values. How many of each kind of stamp did he buy? Again, it's a cost problem, so we could set up a chart for this. So we have the number of each, the price per each, and the total price or total cost. And we have 25-cent stamps. and we have 40-cent stamps. So we know the value of each type of stamp, 25 and 40. And they're buying 15 stamps, so 15 is the total. And they want to know how many of each type, so it really doesn't matter where we put the X. So if I put X here, the number of 40-cent stamps would be 15 minus X. Total cost, you multiply the number times the price per item, so that's 25X. Use your distributor property here. That's 600 minus 40X. And the total value was that he spent was $495. So we're going to add those two up, 25X plus 600 minus 40X has to equal the total he spent, $495. Change it into pennies. Collecting like terms, 25X minus 40X is negative 15X plus 600 equals $495. Solving for X, subtract 600 from both sides. We get negative 15X equals negative 105. Divide by negative 15. And we get 7. So X equals 7, and that's the number of 25-cent stamps. And the number of 40-cent stamps is 15 minus 7, which is 8 40-cent stamps. Problem number 6 says the average of 4 consecutive even integers is 17. Find the integers. So X equals the first integer, even integer. These go up by 2. X plus 2 equals the second even integer. X plus 4 equals the third. And X plus 6 equals the fourth. And they want the average of the 4, so we have to add them up. 4x plus total the numbers 12, and there were 4 numbers divided by 4, that's average, has to equal 17. So if I take 4x plus 12 and divide it by 4, I get x plus 3 has to equal 17. Subtract 3 from both sides, and I find out that the first number must be 14, and checking it is an even number, so it's realistic. So our 4 numbers are 14, 16 going up by 2, 18, and 20. Problem number 8 says Jim's sandwich cost the same as the combined cost of his salad and milk. The sandwich cost 3 times as much as his milk. The salad cost 20 cents more than twice the cost of milk. How much did his lunch cost? Well, let's see where we can start with. It says the sandwich, find something they're building on. That's single. Sandwich costs 3 times as much as the milk. So if I say X equals the milk's cost, the sandwich was 3 times that. So 3X equals sandwich cost. And it said the salad cost 20 cents more than twice the milk. So 20 cents more than twice the milk would equal the salad. And then it says his sandwich, which was 3X, is the same as the combined cost of the salad and the milk. Well, the milk was X, the salad was 20 plus 2X. So I get 3x equals, simplifying the right, 3x plus 20. Subtract out 3x. I get 0 equals 20. This is no solution, and you have to give the reason if it's no solution. It's a contradiction. 0 does not equal 20. Problem number 10 says Janet has $8.55 in nickels, dimes, and quarters. She has 7 more dimes and nickels and quarters combined. How many of each coin does she have? Well, if we set up a chart and then see if we can fill it out for the coins. And we have 3 types. So we have the number of each, the value of each, and the total value. And we have nickels, dimes, and quarters. It says she has 7 more dimes than the nickels and quarters combined. So 7 more dimes than the nickels and quarters combined. But we don't have any idea the relationship between the nickels and quarters, and they didn't give us the total of coins, which we could use. So we're kind of stuck. We know the value, but there's no way to figure out a relationship between the nickels and the quarters. So this one is no solution, not enough info. You can abbreviate NEI. And the last problem, number 12. A rectangle is 8 centimeters longer than it is wide. We're building on the width. The length is 8 centimeters longer than it is wide. If the width is increased by 3, so we're getting a new rectangle. The width is increased by 3, and the length is decreased by 3. So if I take 3 away from that, I get 5 plus W. The area is increased by 4 centimeters. So this is the area of this one. This is the area of this one. So the area of the original one is equal to this one plus 4, because it said it's increased by 4. So 8 plus W times W equals this one, the area of this one. Now this one increased, this went up by, they said by 4, so I'd have to take away 4 in order to get back to the original area. So 8W plus W squared. Use FOIL, 5W, first term, outer term plus 15, inner term plus W squared, last term plus 3W, minus 4. Simplifying first, the right side I get 8W, 15 minus 4 is 11, plus W squared. Then first get the W squares on one side, so we have to subtract W squared. That eliminates them, so we have 8W equals 8W plus 11. Get the W's on one side, we subtract 8W. And we get 0 equals 11, and that's a contradiction, so no solution. Contradiction. Now we haven't seen unrealistic. So look for that as you do the odds. That concludes the evens. Be sure and check the back of the book for the answers.